Welcome to the CoModIDE Screencast. In this video, we will demonstrate the core features of CoModIDE, the Comprehensive Modular Ontology IDE. Note that what you are about to see is an early preview version of CoModIDE, which is not feature complete and which may have bugs. There are certain axioms and constructs which are not yet rendered in the schema view and which might in fact not be rendered in the future either. For instance, properties with multiple domains or ranges are difficult to represent intuitively in a tool such as this, so are left out for now, as is the property subsumption hierarchy. For a discussion on our plans for the development of this software, see our submission to the ISWC 2019 Posters and Demos track. CoModIDE is developed as a plugin to the versatile and well-established Protege ontology engineering environment. CoModIDE complements Protege by providing an intuitive drag-and-drop based interface for creating ontology structures geared towards less experienced ontologists and towards rapid prototyping style modeling. Additionally, CoModIDE complements Protege by providing a built-in library of ontology design patterns that can be easily instantiated by simple dragging and dropping on the CoModIDE canvas. If you want to follow along this demonstration on your own machine, please ensure that you have placed the CoModIDE jar in the Protege plugins directory. The exact location of this directory differs depending on the platform you are running. On Linux and Windows, the directory is typically a subdirectory of your Protege installation directory, whereas on macOS it is a directory packaged within the Protege app bundle. For installation instructions, see the CoModIDE webpage at comodide.com. We will start the demonstration by going to the CoModIDE tab. This tab consists of three views. The CoModIDE schema editor takes up the largest part of the tab. On the right, you also have the CoModIDE pattern selector view and the CoModIDE configuration view. The Schema Editor view provides a graphical overview of an ontology's structure, including the classes in the ontology, their subclass relations, and the object and data properties in the ontology that relate these classes to one another and to data values. Creating a new class is as easy as dragging and dropping the class from the palette on the left-hand side onto the canvas and then double-clicking on the class to give it a name, like so. Note that it is only upon labeling the node that the underlying class is created in the ontology. Let's add another class. To create relations between classes, including subclass relations, you simply select an appropriate connector from the palette and draw between the nodes. Ensure that the node lights up by placing the cursor over the node label when starting and ending the connection. I'm now going to connect my teacher class as a subclass of my person class. If we now go to the Entities tab, we can see what structures CoModIDE has created for us. And here we see that teacher is a subclass of person. We also see that some annotations have been added to both classes. These are positioning annotations created by CoModIDE to keep track of where on the canvas to draw the nodes when saving and reloading an ontology or sending it to someone else. CoModIDE will add such annotations whenever it finds something that it needs to keep track of. If the new node doesn't have a position, for instance it was created outside of CoModIDE, then the position will be randomized initially and it is up to the user to put the node in a place that looks good to them. Let's now add another subclass to person from the class hierarchy view and see these annotations being added and the class drawn on the canvas. There it is, there are the annotations, and here we see it on the canvas, randomly placed. I'll just move it a bit to make it look nice. The next step is to add some properties. We'll start with data properties. Persons have names, which are strings, and birth dates, which are date times. We'll create one instance of each by dragging and dropping from the XSD Data Types tab of the palette. Then we'll select a property link, connect the first data property, and label it name. And then the second, date of birth. Right. And now let's check our data properties under the Entities tab. And there they are. Moving back to the CoModIDE tab, now we want to wire up some object properties. I'll create a class lecture and add some data properties to it. And now we want to connect teacher and student to lecture by two different properties, namely teaches and attends. Now, when I did this, you should also take note of the checkboxes in the CoModIDE configuration view on the bottom right over here. These checkboxes govern which types of axioms that are added to the ontology when a property line is drawn on the canvas. The top two are simply that domains and ranges are added to the properties that are created. The latter two are class constraints that emulate the functionality of domains and ranges, and which are sometimes preferred by some modelers. And I'll show you these shortly. I'll now add another class and relate it via property with all four of these checkboxes checked. So there. So now let's see what happened. We can look at the object properties and we see contains lecture with the domain and range, and attends and teaches with domain and ranges as expected. Let's also look now at the course class and see these additional axioms that were added, what we call the scoped domains and ranges, which emulate the functionality of domain and range. So for every course, it can contain only lectures, and everything which contains some lecture must be a course. Now to the patterns. Going back to the CoModIDE tab, we can see a set of patterns on the right. This is a curated subset of patterns published in various projects and in the ontology design patterns community. Patterns can be filtered by category here. There's a view over the documentation of each pattern, which can be retrieved by clicking on the corresponding documentation button here. Finally, patterns can be instantiated into the ontology by clicking, dragging, and dropping them like so. Of course, we may have to move the pattern constructs around a little bit so the diagram as a whole makes sense. Before discussing how to proceed, let's talk a little bit about the configuration options on the bottom right again, down here. There are two options here that which control what happens when you drop a pattern. The first one, entity naming, governs how constructs inside the drop pattern are named. If you select Keep Pattern Namespace, then the original class and property IRIs from the pattern itself will be kept. If you select Use Target Namespace, then the local names from those IRIs will be kept and grafted onto the target ontology namespace, making them appear as locally defined constructs. The latter option, Module Annotations Placement, govern where the pattern instantiation metadata is inserted. When we drop a pattern, what we are actually doing is creating a pattern-based module to which all of the included classes and properties belong. We use the OPLA vocabulary to track provenance, which classes and properties belong to which module, which in turn was created from which pattern. This metadata allows for modules to be contained such that they can easily be extracted or removed at a later time, or in future versions of CoModIDE will allow graphical on-canvas indication of which entities that belong together in a module that might be folded or unfolded to hide or show complexity as needed. Now, you may have experienced a slight jump here because things moved about. This was a consequence of an unexpected crash in the recording. Our apologies for that. Continuing, there are two options for where all of these OPLA annotations end up. Either in the target ontology itself, which is selected here, internal, or in an automatically generated metadata ontology that imports the target ontology and adds these annotations, which can be selected here. If these modularization annotations are kept external, the target ontology remains uncluttered, whereas if they are kept internal, the target ontology is more self-contained. Since we have the internal setting selected, let's see what happened when we added this pattern. We now see the notions of module and pattern here as well. The pattern instance refers back to the IRI of the pattern that we imported, participant role, into our ontology. The module instance has a GUID-based identifier and has OPLA annotations to indicate that it reuses the participant role pattern and a label indicating that it is an instantiation of the participant role pattern. Finally, we can see in the Usage tab here that all of the newly added classes and properties have the OPLA annotation is native to, indicating that they are part of this module. Moving back to the CoModIDE tab, we can now connect our pattern to our manually generated classes, for instance, by adding a subclass relation between event and lecture, such that lecture becomes a subclass of event. Or we might add another pattern by dragging and dropping to further extend our model. Finally, let's look at how CoModIDE handles opening an existing ontology. I'll start with the Real Estate Core Ontology's Core module. This is a comparatively small and simple module within a larger smart buildings and smart city oriented ontology. I have prepared this module with positioning annotations. When loading the file without these annotations, all entities were clustered here in the top left. So I had to move them out and position them on the canvas. Thankfully, this work needs to be done only once, and CoModIDE then keeps track of the positions going forward. As you can see, CoModIDE immediately provides a bird's eye overview of which classes are connected how, though there are some issues with overlapping labels that may need to be addressed. Let's then try a more complex example. I have downloaded a copy of FOAF for this reason. Again, I have prepared this file with positioning annotations. What now? When looking at this, keep in mind that FOAF uses a lot of equivalent class alignments and a lot of underdefined properties, that is, without domain or range definitions given, which CoModIDE does not yet know how to treat, and which give rise to duplicate or disconnected nodes. That being said, we can see that the core classes and properties in FOAF do in fact show up and probably could have been created and maintained in a CoModIDE-like environment. This closes our presentation. We hope that you are interested in this tool, and you are most welcome to try it out and contribute to development. The code and plugin are both linked from CoModIDE.com. If you have any questions, do not hesitate to get in touch with Kogan Shimizu or Karl Hammer. Our contact details are also provided on the CoModIDE website.